Hey there! So, let's talk about a problem that can occur when trying to link an assembly function with C++ code. The issue arises when we see a segmentation fault after successfully swapping two values using assembly code on an x86-64 platform. The stack smashing detector kicks in, causing the program to terminate unexpectedly. Quite a puzzling situation, right? Now, diving into the solution we provided earlier. The root of the problem lies in the assembly code itself. The assembly function, named scambia, is declared to take references to int, which is 4 bytes in size. However, the assembly code is performing 8-byte loads and stores using racks and RCX registers, overriding nearby stack space. This discrepancy leads to the stack smashing detection and the subsequent crash. Building on the solution, we suggested tweaking the assembly code to use 32-bit registers for moving data in and out of memory. By changing to EX and X registers, which correspond to 32 bits, we ensure that only the intended 4 bytes are modified, preserving the stack integrity and preventing the segmentation fault from occurring. Remember to keep the pointers RD and RSI untouched as there are 64-bit addresses. In summary, ensuring alignment between the data size handled by the assembly function and declared in the C++ code is vital to prevent stack smashing issues. By implementing these adjustments, the program successfully swaps values without compromising the stack. And with that, we've unraveled the mystery behind the segmentation fault. Thanks for tuning in. Don't forget to like, subscribe, and drop a comment below. You never know what tech troubles we might tackle next.